Hey guys, as discussed earlier, we are here to discuss about the image classification, but using Microsoft Custom Vision. So, what will be the difference we will see? Normally, we used to write huge lines of code and run a classifier, run something, test a model, train a model, and we do everything through code, right? Normally, but today we will do something without any code. Like we will not type any code. We will simply type some CLI commands or some URLs, and that's all. Okay, so that's the main motive of today's session. And yes, this session is a part of Azure Azure Pi Day. And what is this? I'll just discuss a bit later. So first let's see what today's exact agenda is. We'll first create a custom vision service project. Then we will train our custom vision service model with tagged images. So for that we'll upload some images with tags. Okay, we will upload, not take some images or something. Then we will test this model, and that's common for a machine learning model. And next we will call our model's prediction endpoint over HTTP. So we have our model and it's not in a notebook IPNYV file, but we will have our model and call our model over HTTP, like we will use it from an user endpoint. Okay, so exactly what we'll do: create, test, train a custom image classification model to accurately identify paintings of famous artists. Okay, first I will take paintings of some famous artists, and then at the end, if time permits, that's important, I will try to show something that's most important, like a different kind of thing. Okay, a different kind of classification, a newer thing. And then just a reminder, I guess everyone knows that I've started a keep GitHub green challenge to for everyone of CIM students, and also anyone can join in. So it's basically keep your GitHub account green for the month of June. So whoever is not that didn't participate yet, you can visit. Yeah. And then this is Azure Pi Day. So this is basically an challenge from Microsoft team, and it's basically you need to learn as an individual and then host as a community, and that's what you are why you all are here today. So you can visit more about this challenge and what is this on this given link, microsoft.com/en slash campaign slash Azure Pi Day. And the next thing why this is important is this part. On Azure Pi Day, there is a weekly challenge for everyone who is in who is interested. So this is not specifically for students, but yeah, anyone can participate in. So what's there? After the weekly challenge, you can collect your Azure Hero badges, and these badges are quite a point of show off, you can say, or you can like show others that you got these badges, and this has some importance. It gives you NGX Bitcoin, I guess. And then moving on, wait, there is something more I will tell, that on this weekly challenge, you just what you need to do, you need to use Python and Azure Stack to create an app or project. And then like this project should solve some problems or inspire new inventions, and then ultimately tweet your creation. So if your project got gets selected, you will be notified via Twitter, and then you may receive your Azure Heroes badge. And it's all there in this website. You can just visit here, Azure Pi Day Microsoft campaign, and you can receive it. Okay, so let's start our session. So we will be using Microsoft Cognitive Services. Cognitive Service is basically a suite of services and APIs. Okay, this uses ML algorithms, obviously totally ML algorithms, but you will not write anything. Okay, Then it gives you intelligent features like you can do face recognition from pictures or videos, and then you can move on to sentiment analysis in text, and a lot more you can do using this. I will just visit this site a few minutes later and show you what you can do over there. Yeah. Okay. Then the next thing we will use is custom vision service. Custom vision service is basically the newest member in this cognitive service suite. And why is it like it's out in market is specifically to create image classification models. Okay, so you will learn like you will upload labeled images, and custom vision service will help you uh, classify images. Okay, then so we'll follow few steps today, and the first one is obviously create custom vision project, then upload tagged image, and then train test model, and ultimately call the model's prediction over HTTP. And that ends my PPT over here. I will move directly to the browser window and show you something. Wait, let me just share my browser window. Uh, yeah, one second. One second. Yeah. So here you can see I am using customvision.ai. So if you, I'm giving the link in chats also. Just you can visit here too. Yeah. So this is customvision.ai. So after you visit customvision.ai, you may require to sign in, and for that it's better to use your Microsoft account, that is Outlook account, and that then you will reach somewhere like this customvision.ai/projects. And yes, I am using here the my student partners account, and so it's showing that. But for your case, it will show Outlook or some other account. So what we'll do, we'll create a new project, and then first thing is name this project. Say this will be artworks, obviously, but I'll say artworks 1 since I have one project already called art 1. And then for this resource, you can see it's already selected for my case, but why not, I will create a new one, no problem. Say I name it custom vision resource 1, and I have a subscription, and yes, it needs Microsoft Azure subscription for you, but no problem. I will tell you a way you can get Azure for free. For students, actually, I will tell you. But first, look here. For resource group, I already have resource group. This one I will use this resource group. So for Azure resource group is basically you can say a bundle where all your resources are there. A specific task resource are put in a resource group. Okay, so that you pay for those specific tasks and you don't need to pay for everything here and there. You are just paying whatever resource group is there. Is, you can say, a kind of folder in your computer. Okay, where you keep your particular sort of resources there. So it's useless to merge up what you to keep other resource in a different resource group. So make a resource make a resource group specific to some purpose of resources. And here for this kind we will take a cognitive service. So we have two other options, that is cognitive custom vision training or custom vision prediction. But for custom vision training and prediction we can perform that specific task, but we need both, right, for training and prediction. So we will take custom vision services. And then there comes the location. So for location you can select central India is location is there, but selecting south central US is the best because the server is on south central US. That would help you in that purpose. And then the pricing tier, you can see there's F0 written here, but F0 you cannot F0 is free tier, you don't need to pay for that. For S0 is the first payment tier. So yes, we cannot select F0 for customization. We need to select S0 and then create resource. So what will it do? It will just create a resource for us within this resource group. Just wait a minute for this to be created, and I can show you where the resource got created. I will show you. Just remind me at the last if I somehow miss out. Okay, then after we selected this resource, then the task is project type. For project type, custom vision gives us two options, either object detection or classification. But I mentioned that in the beginning, we will be classifying the artworks of various artists, right? That was the main target of our project for this session. So we'll do classification, but for object detection, we can select object detection too. For that, it will be something else, okay? We'll say classification. Next thing is classification type. For that, you attach tags to images when you install when you write codes in Python, that you are adding tags that uh, this image has this things in it. So while classification, you need to add tags too. There's an option you can add a single tag per image, like a particular tag, or you can select multi-level to add multiple tags. Yes, we will select multi-level because the image can contain multiple tags itself. Okay. The next thing are domains. We will keep it general because the other domains are food, landmarks, and retail. We don't need this. We are supposed to do something with artworks, and so we will keep it general. But if you are doing something specific to food, landmarks, or retail, then keeping it on retail is better. And yeah, for if you select general compact, there's an it will show you something else. But yeah, what is this? Compact domains are basically lightweight models that can be exported to iOS or Android. So if you're selecting compact, then the main purpose would be to export this to iOS or Android. But since I am currently working on my desktop or Windows, so I don't need compact right now. Okay. So that's the main thing. Then create project and wait a minute. Our project will be here in seconds or minutes. Yeah, it's done. Cool. So we got our project. This is the whole section we have. So let me just uh, tell you something about this. Here you can see a train button is there. Use it to train your model. And this probably won't work now. Okay. Since we have nothing, so keep it aside. For training images, then we have something called performance to check how our model is working. The same thing we check in notebooks. What is the output of the model? What is that? What happens when we run some code? We can check line by line, but for model, we will check here through performance tab, and through prediction, we'll predict our images. Okay. So first task is to add our images. Okay. Go ahead and add. So basically, I have downloaded. Few oops, wait. I have downloaded few pictures of Picasso, Pollock, and Rembrandt. Sorry if I'm pronouncing Rembrandt wrong. And so first, let me just add all these images of Picasso. So yeah, these images are getting uploaded. So we'll add a tag like sorry. We need to do something first. We need to add tags first. So for tags, it will be like, let me just copy and I just kept all this in a notepad. So first thing we will copy is painting. Painting is here. See, it got painting tags added here, and then we will take pull off. Oops. Yeah. We will add Bullock here. Then we will add Picasso. And at last we will add this Rembrandt. It doesn't matter in what order you are adding them, but yeah, Adding a tag is basically adding, telling it that it has this kind of tags. Okay, so it basically takes that you added. You don't know what it means. The next thing is add image. So yeah, here I have few images of Picasso, and I'll just open them, like upload them, and tell them machine learning system that yes, it's a painting and it's a painting by Picasso. Okay, I uploaded Picasso's image, and yes, it's a painting of Picasso. So our uploading is done, and then let's upload other paintings by other artists. So we'll add Puller, then again we will say it's a painting and it's by Puller. So it's done, and we'll add the third category, that's by Rembrandt. So we'll tell it's painting and it's by Rembrandt. Done. We uploaded the image. Okay. See, till now we are completely working on cloud server. Okay, we didn't use any of our local machine, and we are completely on cloud server. The next thing, we uploaded our images, right? Next thing we need will do is train the model. Just train. Just two types of train that you can see here. It's basically quick training and advanced training. For advanced training, if you just click advanced training, its minimum is 1 hour. That is, it will take 1 hour to train, and the maximum is 24 hours. So yeah, you can understand what is the level of training it will give up as an output, like after this training. So since we don't have 1 hour to wait for this training to go on, we'll just go on with quick training. And yeah, so in this case, I will tell you something regarding the regarding these iterations. What are these? Uh, after, like each time you train a model, a new iteration is created. Okay, so you can see here that this iteration and its training is going on. So it says iteration 1. So I'll just reduce it to 30%. Okay. So I'm describing one by one what these things are. So each time you train a model, new iteration gets created. Okay. So custom vision service maintains several iterations for you that basically allows you to compare your progress over time. Okay. So every time you make some changes to your training set, or whatever it is, so custom vision allows you to make, like, you can compare your progress. So when your iteration is better, okay, and then you can see the training is finished. Okay, now there's few things you need to know about this precision and recall. Okay, so precision and recall, like, let me give you an example. Suppose the model was presented with, say, 3 images of Picasso and 3 images of some other artist, say Van Gogh or some other artist. And then if I give an example that two of the Picasso samples, uh, the model says that two of the Picasso samples is Picasso. Okay, the model can correctly identify two of the Picasso samples, and then but identifies two of the wrong Van Gogh samples as Picasso. So what happens? You get 3 images of Picasso, 3 images of Van Gogh, and if it can identify that 3 images out of 3 images, 2 images are of Picasso, and it wrongly, like incorrectly identifies 2 images of Van Gogh as Picasso. In that case, the precision would be 50%. Why? Since it's definite, it identified 2 out of 4 images correctly, right? And for this recall, you can say the recall score would be 67% in this case, because it correctly identifies 2 of 3 Picasso images correctly. Okay, Like I hope you can understand that if you just give it examples of images, so how many can it can identify correctly is recall, and what is the its precision on identifying the images, or like what the amount of images there it getting identified is basically the precision. So you can check the precision and recall, and that's what matters for us. So if you just change this probability threshold in machine learning while writing a code, you at many times notice that you just give a probability threshold for that. So changing the probability threshold would change your precision, recall, and others. Okay, you can understand why the changes are. If probability threshold is 100%, then everything will be 0. Look, so that's how it's working. And okay, so here are the so our model is trained. Since it says our model is training finished, so we should try something. Like let's give it something to identify, right, whether it can identify or not. We need to test our model, right, whether it's working fine or not. So go ahead, click on quick test. So quick test will give you some options of uploading image URL or local images. So I will go on with local images. I have those here. Here I saved something for quick test. Here, look, this image. This image is the image of Picasso, and I renamed as Peak Test 1. And there is one more image of Picasso. I kept it name as Picasso Test 2. So first, let's test with Picasso Test 2 and see what it gives. Uh, I hope you guys can see. Yeah, this is a Picasso image, and for that purpose, you can see it says 99.9% is a painting, and 99.5% is a Picasso image, and others two are 0%. So yeah, our model is working fine. Let's test it against some other image. Say this is peak test. I renamed as, but this is an image of Picasso. Yes, and again says 99.9 is painting and 99.9 is Picasso, right? You can understand that condition. Let's take some other image that is not of Picasso or of no one. Okay, so let me take this uh, flower image. Okay, tell me something, like you can see the dialog box or not? There's a dialog box opening up whenever I try to open an image. Just tell me if you can see that or not. I don't know what's the status there. Okay, so you can see this image is by Albert Williams. So it says it's a painting, and that's 68%. So it's more than 50%. We can say yes, it's acceptable kind of thing. But for Picasso, it's 1%. Rembrandt is 0.2, but Pollock is 0. So yes, we can understand that it's neither Picasso, not Rembrandt, not Pollock. So this way our model work. It can identify. So let's give it some other example from Van Gogh. Yes, this is an image of Van Gogh, and then you can see it says painting Picasso. This way it works. Okay. The next purpose we need to do first, close it. Yeah. Then visit prediction, and by visiting prediction, here you know that these two images are of Picasso, right? You know since we added this. So why not add a tag to that? That it is a Picasso and it is a painting. Okay, so you let the ML model know that yes, it did it rightly, and yes, it saved it. Then we'll just add this too, and this will improve your model actually. So it's useless, you can do or may not do, but yes, it will improve your model and ultimately save it. So we are left with two images, but these are of no variety, so we'll keep it as it is. Next important thing we need to do is that we will view our model on an HTTP server. Got it? Like we will receive an JSON file out of our images, right? So that we can parse that JSON file in some other purpose. We can use it in our website. We can use it in other services, say in your phone, in your whatever it is. You can use it in your website, phone, and apps. So for that, we'll again move to performance, and in that performance, we'll select publish. So yeah, we'll select publish, and publish says model iteration 1 was our iteration, and we'll select our resource group, that which resource we are publishing, and then publish. So we got our published iteration. Fine. So wait, before I click, I'll tell you. So here is our prediction URL. What this does, this gives you an URL which you can use to check your prediction. Cool. Here, basically here there are two things. You can see, wait, yeah, you can see that there's what's happening? I guess I am on okay. So basically, there's an if you if you have an image URL, you will use this section, and if you have an image file and you will upload an file from local machine, so you can use this section. Say if you are building a website where the user will upload their file like their picture from local machine. Okay, so in that case you will use this section of the code, so that you can parse this like you can identify, let the user identify, or if the user is using an image URL or bringing image from website or whatever, wherever it is, so you will use this section. Where you will use, I will explain that. But remember, you need to copy this codes, and you need to copy this prediction key. So this is the key or the endpoint that is used for this prediction purpose, for on that or basically the API queue, you can say the API that is used here. Okay, so let me tell you a few more details about this thing. This prediction key uh, like has to be set at the header in all requests, that this key gives us access to the endpoint. The endpoint is our website or our application, mobile application or something. So this prediction key just gives us the access, like that entry point or that access, the key to our uh, application, okay, to our model. And this request URL, the URL that you can see this thing, this URL I'm talking of. So this request URL is basically the it's basically the URL which just calls the, like it puts the our application to this place. Like if you just look at to this URL, like we chose Central India, and then you can say this is an API, and it says custom vision, and wait, I'll just pass it. You can say iteration 1. So this is the our resource ID, that resource we created. This is the like ID that is. So it basically points to our Azure resource that we created. Okay. Then there you can see the content type, this thing. So content type is basically if you're posting a raw image, uh, we set the body to the request, uh, the binary representation of the image, and the content type uh, should be something like octet string, like application octet string. Or if you're posting image URL, we put JSON in body, and the content type is application JSON. Look, if you're putting URL, then it is application JSON. Or if you're putting an image, so we need to parse this image and find its each like the raw image, like we need to parse in binary representation, right? So for that we need the content type as application octet string. So every details is here. You don't need to search or whatever it is, but every detail is here for you in this small dialog box. So yeah, we will use these details, so keep it open. We will use these resources. Next thing, we will like the best practice is to keep this things copied and go ahead. So next thing we will do is, okay, let me just share you something more. Like, stop sharing the screen here and share the screen from here. So this is my notepad that I kept here. So here you can say we'll just use our resource now, add a command line input. Okay, so for that we will replace that endpoint URL with our, okay, let me share the complete text. In that case you can understand better. Yeah, so we'll do this. We'll take image URL complete link. Okay, we'll replace it here. Then it says our prediction key. So again we will replace our prediction key with this resources, that this key. We got our prediction key, we got our URL, and remember we are using curl here. I will just use it. So we are using curl here, and curl is basically a bash command, you know, that helps us to import HTTP, HTTPS or FTP. This kind of all protocols can be used through curl. Okay, so look, let me just remove it from here. So here you can see we have added an URL specifically at this place. So this URL is basically an location of image, then that's we are taking from GitHub, and that's GitHub image source. So this is the particular image that we are taking at to locate the test images. Okay, so we are taking the URL. Now next important thing is copy this part. Okay, if we need to change anything, we need to change this URL from next on. Since we are using this curl link is common and the prediction key and content type is common, so we'll just change this image location or image URL next on, and we'll get what we need. So let me just copy this thing, and so next move on to Azure CLI, that is shell.azure.com. Wait, that is Azure Cloud Shell. Wait a minute for it to load. Yep, we got our Cloud Shell. So paste the code, we copy it from there. Okay, this got it here. Look what it does now. Super. So we gave our curl URL, and then it returned us a JSON file. So what it says, it initially it gives you the exact details of ID, project, iteration, all that. Then it says that the probability was set to no, the probability of tag name painting is 0.86, that is 86%. Okay, then the probability of being Picasso is 0.25, that is 2.5%. Then probability of Rembrandt is something this, okay, just convert it to percentage. And probability of Pullock is at too much negative probability. You can see at my, this is here. So you can understand that, wait, this gives you an JSON file. So isn't that great for creating an yeah, something in websites, so that you can use directly your JSON file and till now you didn't write any code, right? If I like, oops, I clicked somewhere else. One second. Yeah. So till now you didn't write any code, and that's important. You tested your model, you are taking a complete JSON file without writing any code. So why not test it against some other images and some other images. Wait, let me just get some images for you. Yeah. Why did I? So I'll just change this URL in this notepad. So again, I will just run it. So I change the URL and then look here. Wait, let me just show you this difference. If you can see, this is test image slash Rembrandt test. So something a different image. Okay, but earlier we used Van Gogh. Okay, so yeah, after doing this Rembrandt test, we get that the again all these details, JSON details, and after that in this prediction tag, we can see that Rembrandt is 77%. Probability of painting is 49%. Okay, so thus we can see that yes, we can receive, and obviously Picasso and Pullock are something much lower probability. It's e to the power minus 0.5 is there, and live those. So you can see you can directly get in JSON file to parse in your website or folders. Now, this is a small thing, right? Where you figured out run uh, how to run your machine learning model, but you didn't write a single line of code. So I've told you that if time permits, I will try to classify some different things. So what is that? Let's try to classify from images that whether persons are wearing their face masks or not. So do you guys like to see that? Just speak up. That would be fine.
Yes.
Like we'll try to okay, fine. I'll just move back to custom vision API, and that's a project here. And let me go back to project again. Then why not build something like that? Let's try to figure out our whether person is wearing a face mask or not. Okay, so give it a face mask. Any name will do. No need. This is leave it there. Rest one, fine. This is object classification. We need multi-level. We need general, and this great project. Super. Give it a second, and this is done. So we will do something. We'll add tags. Say, tell me what can be the tags. Tags can be human, right? It's necessary that someone didn't put a mask on a dog and didn't show that picture here. That's important. Then task can be with mask. Got it? With mask, and tag can be without mask. So basically, I didn't try this doing before. Trying to build this on spot. So I don't know what will happen ultimately. So I have few pictures of people wearing mask and people not wearing mask face. So with mask, I have few pictures, and wait, I will not take all. I will give few images for later to test and train. Okay, let's give this 3 images on left. So here you can see we have human and we have with mask. Okay, upload 12. Then upload done. Super. Then we'll add more images. Okay, for so that no one gives a copyright claim on this video. All this pictures are from Unsplash, and I guess those are not copyright claimed images. So then I will try to take this 8 images and say this is a human and they are without mask. Fine. Then upload 8 files. Super. So we got our images done. Next task is train your model. I don't know whether it will work or not, but hope for the best. I prefer threshold to be 30%. No problem. If it's 50%, will just give a lower recall value, recall percentage. Yeah, wait for it to get trained. We'll test it against something. So, come on, get trained. Okay. So till this time you all are here, let me just it gets trained. Let me just share something. Fine. Let me just share something. There's something ak.ms slash yes, that's the link, and it has a lots of information, like lots of resource for you guys to work on. Oops, what's the problem? It got a high recall value. I need to think more on this. I don't know whether how much it will work or not. So this is a random project. We need to work more on this. Let's see what it gives. Okay, fine. Then get a train. Test our model. So we will do test on, say, there's a thing with marks. I left these 3 images. I'll just select a with mask image and see what it says. Uh, yeah, it says it's human and is with mask. Yeah, it's giving us correctly. Then try to wait someone. Okay, I have like traced one more with mask. Yeah, it's giving us a good result. I think we need to test it against a test folder. I have some great images to test. Let's test this here. What it says. Yeah, it got us right. It's human and it's without mask. Look, still half of the face is covered here, but still we can see that it gets without mask. Try out something else. This one. Oh, it says it's with mask. This is wrong. Okay, this needs to be corrected since it had something on his face, but not a mask. That's more important to know. Then try out some image like this. Uh, 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 It fails to identify it as human, but it says without mask is 6%, but with mask is 0%. So at least we got our result as we expected, but the probability is low. So we need to improve this model or work on it. Say if we just give a different image, this says without, okay, this is a good result. It's a human, okay. With mask is 7.6%. That's a lower percentage than without a mask. And yes, you can see it's without a mask, right? Like I have so many images here. Okay, look at this image. Yes, it got confused. Tell me, if you are there, what will you say? I don't know if this image has some different meaning or not, but I just took this image for understanding whether with marks or without marks, how the model classifies it. So model says its with mask is 39.6% and 36.8%. So just speak up and tell me whether like what will you say to this, with mask or without mask? Anyone? Speak up. Oh, you are writing text probably. What do you think? This is with mask or without mask?
This
Without
is with
mask.
this is with
But
marks.
with
With
mask.
marks.
Okay.
Yes.
Okay. So in chats, two people are saying without mask, and you are saying it's with mask. Okay.
It's with mask, with mask.
Okay. That's a 2-2 4. Impossible. Let the and the ML model also said the same thing. It's confused whether it's with mask or without mask. Try something else. Yeah, it's common, it's without mask, but that percentage is lower. Okay, so that ends this part. We need to do the predictions correctly. So let's tell our bot that this image, the image we saw here, is basically human and is basically without a mask. Okay, it says it with mask and it was 80%. So we are telling no, you were wrong, and it's without a mask. And then we'll take this image and we'll help him identify that is a human and it's without a mask again. Then select this image. We're just trying to help the bot, like, okay, this is, oops, yeah, this is without a mask. And yeah, it was quite right. So let's keep this controversial image ahead uh, and do a train again. So we added few of our values. We're getting iteration 2. We told him that okay, this images are without a mask and this images are with mask. Right. Then let this training finish in a minute. Come on. Yeah. Now, now you can see there's a fall in position and recall. Yes, there's a fall in position recall. So go ahead to predictions and yeah. Next, we don't have an image here. So, oh, sorry, I should go for quick test. So for quick test, go ahead and take images like this. Tell me what is this? the it found out it's without a mask. So you need to improve it, right? That it's with mask and yeah, there's something problem with it. The bot needs to understand that. Then let's take this image. And it says it's without a mask. Yes, that's right. So this way you can just go on adding your wait, let me add one more image, and it again says without a mask is there. So you just go on adding your images and ask your bot and train your bot that hey, these are these images and you just got it right or you just got it wrong. So it's human and it's with mask. We're just informing it and it got it results. Okay. So again, we need to train. This way, you will just improve your bot performance. And the most important thing is don't work with such small number of data set. And a huge data set helps the bot understand better. Okay. So that ends our part, but again you can do something publish it, then the same thing we did here. Okay, publish it, then get a publish URL. So you just put it and get a JSON file at the endpoint, and that's this part. Okay, so that's not a big deal. We'll directly move to the ending part. So why did we, like, why we need to do this, right? Why you should not go to coding these things rather than you will move to custom vision. This is the main question you might come, like, hey, by coding I can learn, right? So yeah, if you are thinking of learning ML and you are thinking of learning the whole process, how it works, or you're thinking of working with some research work or building something that's not in this module, so yeah, go ahead with coding. But if you are short of time and at the same time you were like working with such like huge industries, and then you were like you need to automate this task, like you are just, you have a website where people upload images. Say you can take an example of Facebook, and say people upload a lot of images, or Instagram. So there can be times when people upload offensive images and you need to check. So for that purpose, will you go to write a huge lines of code, or you will on a quicker note you'll just come and get a prediction URL and use it on your functions? That would be much faster for you, right? Writing a huge code, checking when the code is working or not, checking every line, correcting code errors, and all that is tiresome. Okay, so this is what you should do with your custom vision AI, like API. So I think that's all for today's session. And tell me if you have got any questions. Ooh, I'm just
What is negative tag? I saw somewhere in the screen.
okay. For that, negative tag is basically your wait, yes, they are in images, right? Yeah, when you are adding something here, it's saying is negative. So if you are adding some negative tag, it says um, the particular image you are uploading, it's opposite to the others. Anymore? Okay, I think they're not there with any questions. So thank you guys. And yes, that's aka.ms/Azure PyDay. Visit is probably an uh, GitHub repository, and it contains all those files that you need to learn to just work on. Let me check. Yes, it's a GitHub repository, as I say. So that basically helps you to work on any other projects or take part in that Azure PyDay weekly challenge. And thank you guys for joining in today.